deep embedder is an autoencoder that is designed to perform unsupervised clustering and synthetic image generation using astronomical imaging catalogs using Astro VADA. They clustered and therefore classified radio galaxies according to their morphologies and also generated synthetic LOFA images. Let's welcome Dr. Kusata Ndoesile. Are you online, doctor? Let's just give our technical team a few moments to show the video. entrepreneurs, techpreneurs. She has money, by the way. Right?
Joseph, I think what I've learned from the morning sessions is that we've all been these things coming up as the youth. I think we have sort of like a responsibility to go into that space, and also that organization, universities come together and sort of tackle also the skills that we might have. So yeah, with regard to what we're building, I think one takeaway point is that we need to build solutions which can cater to Namibian problems. So yeah, if we can localize some of these AI, where it says sort of like how Dr. Stanley was saying that LLMs cannot really work well in local languages, and they only work well with languages like English and so well resourced. So yeah, if we can do that, perhaps in local language, maybe sort of LLM, Oshiwambo, any kind of language that can come with, then I think that would be best.
Beautiful. So Mr. Matukange is also an enthusiast of deep learning and machine learning. And I can tell from the reflection that is geared to bring some solutions. And finally, we are going to hear from Beijing. I think it was back in the 80s when there was a Beijing convention which was supporting the inclusion of women everywhere, especially in the fields of science and technology where we are always underrepresented. And this room is a testimony of that. We still have less women to males. So, Madam, let's hear from you.
What I've learned is the world is AI to ML. And I feel like we could use that to better things that will also cater the unemployment.
The youth are all about employment. I thought I was going to hear how to nurse children, Children annoying, they can cry all night long. So if AI could be my nanny, I could go to bed and sleep nicely, So yes, for those that I haven't reached out to, I didn't forget about you. I just saw that Yakub is ready. So let me allow him to take the floor. Then I'll come back to you.
Okay, thank you very much, ma'am. Good morning, everyone. Thanks for having me here. Thanks for giving me the opportunity to come up and speak to a bunch of like-minded individuals, those experts in the field, those trying to gain a footing in the field. My apologies. Actually having an argument.
Somebody posted thing on social media.
It's a great start to the presentation. We meant to do that. That was just an example of what you shouldn't do in the space, right? Thank you very much, Doctor. Appreciate it. So apologies for being late. I was having an argument with ChatGPT about which is better between Marvel and DC. The guy claims that he's not allowed to give an opinion, but he was very opinionated towards DC. So that's where we had an argument. But thanks again for having me here. My talk would be a little bit of a technical talk to kind of give you an example and put you through the steps that you need to take if you wanted to actually get in depth and build something of your own, because these talks are great, you know, in the sense that you get impacted with a lot of knowledge, but at the same time, when you go home, you'd like to actually build something and put that to use, even if it's for the smallest of things, right? So my talk today is mostly just about vision, computer vision, right? So when we're talking about computer vision, there's different types of things you can do with it, right? There's classification, which in other words is showing something on the screen and the computer tells you, based on what I'm looking at, this is what this is. That's what we would call the normal classification. Then we have localization, which is the same thing as classification, except it tells you what you've shown me on the screen is A, and this is the bounding box of where A is, classification and localization. And then you have object detection. This one is a little bit more complex and in-depth, right? You get a lot of images on the screen, a lot of objects on the screen, and the computer tells you, this is what this is where it's located, this is what this other thing is, that's where it's located, and so on and so forth. And that's where we now have the object detection. And then we have instance, which in other words is just showing you how to draw bounding boxes around the items that you need exactly where they need to be, right? So those are the different types of visions, computer vision that we have and different use cases. Some of you might have already seen this in action, right? We have Tesla, for example. There are self-driving cars that have been coming soon for like the past 15 years, right? The way they work is they're able to detect what a traffic light is because they use object detection. They're able to detect what another car looks like because they use object detection, you know, instant segmentation, so on and so forth. Pedestrians, roads, all sorts of things are just an example of computer vision. Now, I know you sit there and you think Tesla, great device or great company. You sit there and you think NVIDIA, great company. And you sit there and think, those guys are doing great. I don't think I could do that. But you could actually build your own image classification model in a day, right? It's not going to be as smart as you'd like it to be, but you can actually start and build it in a day and experiment to do whatever it is you need to do. You can use real world examples, right? Say you are someone who likes a certain type of candy, okay? And maybe you get a huge bag of candy. Maybe you're visually impaired, right? You have a partner or a crush. You have a crush on someone who's visually impaired, right? You like to buy them their favorite type of candy, but when you buy them that box of candy, they won't be able to pick to say, I actually like only the green jelly babies, right? Or only the jelly babies shaped this particular shape, and you won't be there with them all the time. So what if you built an image classification model that allows your visually impaired partner to lay out all the sweets on the table? The computer takes a picture and says, you have the green jelly babies at this position, at that position, right? To help them pick out the jelly babies that they like. That's an example, an easy example of how you could build an image classification model for your daily, everyday use and to impress your crush who can see. But they can see that you're a good person, right? If you build them an image classification model, right? So that's how you start. So getting ready to build your image classification model involves machine learning, neural networks, a little bit of math, some configuration. And I know what you're thinking. You're just like Homer, you're like, no, this is not for me. I'm sorry, right? When you joined computer science, when you took up a field in tech, you probably searched the highest paid salaries. And you saw that data scientists, machine learners, they make a lot of money. And you thought, this is it. But this is actually a little bit of what you have to do. And it's not that complex. I know you're thinking, I have to build my own model. It's not as complex as you think, because with the power of TensorFlow, which is a product from Google, and we all know Google makes great things, except for Bard. Google Bard, except that they make great things, right? So TensorFlow is a sub-product of Google, and it's pretty much a massive library built by people like you and me, people who sit in their houses all day, the nerds, as we call them, right? People who hack Zoom meetings, right? They're the ones who make these models for us, and they put them together in this library, and we can access them and use them to do whatever it is we want to do. So TensorFlow can do things like image classification, object detection, text annotation, video classification. You can even build your own chat model, right? With the power of TensorFlow. So with TensorFlow, it's in other words, just an open source machine learning toolbox. I put the URL there. You can take a picture of it. You can try and visit it whenever you get the chance to. It's simply a open source machine learning toolbox that allows you to find pre-existing tools that allow you to do what you need to do. So if you were trying to build a gummy classifier for your crush, right? You don't have to start from scratch. You can simply visit TensorFlow, look for a tool that matches what it is that you're trying to do, configure it, and build the thing that you want to build at the end of the day. And that's TensorFlow. I'm here to introduce to you TensorFlow, all right? So how it works is with any vision or image training data set, you need a few things. You need your data set, right? You need to test it, you need to train it, you need to test it, you need to validate it, and then you need to deploy it. So for those of us over here, you start your journey being that person on the right. I don't know why anyone would type standing up, but let's just assume it's a coding bit, right? So you're standing somewhere in a dark room, you've got your hoodie on, you're typing a lot of green characters on the screen, you're training your data set, you deploy it for Tangeni over here, who has a picture of his dog, right? Or say maybe he loves dogs. He goes to SPCA, there's no one around to help identify the species of the dog, but you are an expert with working with animals, right? So you build a species classification model, in which if you take a picture of any animal, it tells you what species it is, right? For those of us here who love dogs, I will not throw any shade at anyone who owns a cat. We all know how cats are, but those of us who love dogs, right? We have different brands. We've got the golden retrievers, we've got the Labradors, we've got the poodles, all sorts of, but you would like to know the specific type of poodle or the specific type of golden retriever. Someone would build that model for you, deploy it, and you can use it on your phone. Either you just take a picture and the model will tell you, hey, this is a picture of a French poodle, or this is a picture of an Oshiwambo golden retriever, right? Or what was that husky that they found in the north that they decided was witchcraft? But if they had an image classification model, they would know that this is a dog and not a witch, right? Yeah. So those are just use cases of how you can use your image classifications to build something you like. And you don't have to start from scratch. Again, there's a URL there for you. You can visit that library, GitHub library, provided by Google, TensorFlow exactly, that just showcases all sorts of different types of models you can use. Their performances, the papers where they're being referenced, you can go and see them in use cases. You can see them how do I actually build from start to finish, but you don't need to actually know all that information. You just need to know how to use it and what their performance benchmark is. Because one thing that you need to notice or to realize is that when you're working with image classification models, your performance is very important. If you're trying to build your own classifier and you've got maybe 100 models that are pre-existing for you, you would want to choose the one that has the highest performance rating. Some models are really smart. They require a lot of resources to get to work. Some models are not as accurate, but they run fast. So depending on your resources, if you've got an NVIDIA TPU, then maybe you can use some of the models that require more resource-intensive processing. If you have just a basic laptop that some guy at Hi-Fi sold to your parents, say, this one, yeah, this is the one. This is your laptop, right? We all have people who buy us laptops and they're not the best. So if you have a laptop that's not the best, you wouldn't want to use a resource-intensive model. You might want to use a less accurate but easier to run model. And that's what these benchmarks here on this website will show you. So once you've gone there, you figured out the model that's you got it? Thank you. It's also part of the presentation. Thank you. So if you had a model, you're thinking, how do I get started? The first thing you need to do is gather your data. You'd ask yourself, what exactly am I trying to classify, right? Are you trying to classify humans? Are you trying to classify animals? Are you trying to classify single women on the market if you've been, alone for a really long time? Are you trying to classify tall people? Are you trying to classify the facial expressions of everyone in this workshop right now? So in my example, we'll be using we're going to be building a little bit of a facial image, a facial recognition type of detector, right? So as you sit here in a Zoom class, sometimes you're talking, people have different facial expressions. You don't know if people are happy with your presentation. Are they confused? Are they sad? Are they afraid? So what if, for example, right, it's your first day teaching. You're teaching a large class. And in the middle of your presentation, say every 15 minutes, you would like, for example, the camera to snap a picture of everyone and get an idea of what their facial expression is. So if most of your participants are smiling, it means you're doing a great job. It'll just give you maybe like a thumbs up. If most of them look confused, it'll tell you, hey, buddy, slow down. Your class is confused. But you're not able to tell that because you can't go face to face. No, you can't do that. You'd rather have the microphone do that for you and tell you exactly how people are feeling. So that's what we'll be building today. So how do you get started? You must get a vast amount of facial expressions. Thousands, not hundreds, tens and tens of thousands of facial expressions. Build an accurate model. You need tens of thousands of images of what you're trying to classify, right? Tesla and knowing how to classify a traffic light, tens of thousands of different traffic lights were taken pictures of, different angles, different weather conditions, different times of the day. In the nighttime, whether it's raining, whether it's snowing, thousands of images. So if we're trying to build a facial image recognition data set, we're gonna need pictures of people's faces, right? Luckily, you have this platform called Kaggle, Kaggle.com. Kaggle allows you to go and find all sorts of data sets that you might need. They might not have everything, but they have most of the data sets you need. Animals, common household objects, cars, facial expressions, maize plants, mahangu plants even. And the good thing about Kaggle is if you're someone who's trying to build a data set and you don't have that data set, Kaggle allows you to upload your data set. So if you have someone trying to build an image classifier to find maybe crop plants for your village in the north, and you don't have images of those online, you could literally get those kids, maybe take pictures of all your plants and then upload that as a Kaggle data set. And you know what you've done? You've created a data set for millions of other people worldwide, right? But again, it's kind of daunting because you have to take thousands and thousands of pictures, but you can start and have somebody else add on to your data set. So Kaggle is my go-to source for data sets. And for our facial image recognition test that we're going to do right now, I got those images straight from Kaggle. They have a data set that allows you to, that has people that are angry, sad, upset, confused, in fear, all sorts of different facial expressions. So I collected that data set and I'll show it to you later on. And what you need to do after that is split it up into the folders. I call this manual classification. So the way image classification works is the computer can only tell you what something is if you've told it what it is first. The computer can only tell you that this is a green gummy worm if you've told it before that this is a picture of a gummy worm. Same with a sick maize plant, same with a single lady, right? So after you've collected your data set, you split it up into different folders, which are your classes. Classes are, in other words, just categories. So get all the pictures of the people that are angry, put them in one folder. Get all the pictures of the people that are sad, put them in one folder. Do the same for the happy and all your other classes, and you split that up into a data set. Training and testing. When building a model, you need a training and a testing data set, right? So it's best to usually go for an 80-20 split. If you've got 1,000 images, use 800 of them to train and 20 of them to test. And for you to validate that it's actually doing the right thing, take pictures that your model has never seen before. So when I mean a vast data set, you will really need a lot of images, right? So after you've classified your data manually, you go ahead and set up your environment. My favorite tool to use is Collab. It works the same as Anaconda. It's a Python library or Python interface that allows you to use Google's resources to actually build something. Now, remember what I said, some people might not have the fastest computers, or if you're using a basic generic Mac, it might not be able to process things as fast as you'd like. Fortunately, Google Colab gives you these high-end resources. Of course, they're kind of like rented out. So maybe after 2 hours of using it, it'll tell you, hey, buddy, your time's up. Maybe come back after 30 minutes. But that's a small price to pay, right? Because in 2 hours, you could train it to do a lot. So Google Colab, if you Google Colab, it'll take you to a platform where you can actually get started with the basics, right? So for my experiment, we'll be using Google Colab. Now, if you do not have a lot of hands-on experience with Python code, luckily there are step-by-step guides on Google Colab. So once you've set up your environment, you go ahead and do the things you need to do. You load your images, right? The images you collected. You split them into your training and testing data set. You configure your data set for performance. You standardize your image data set. You choose from a predefined model, right? After that, you compile your model, you train your model, you visualize how smart your model is, and then you proceed to test the model on gummy worms that it's never seen before, gummy bears that it's never seen before. And all of this I will showcase in the practical example after we get through the slides. So after you've collected your information, you've put it up on Google Colab, you've configured your data set, you train it and you just wait. Training your model is as easy as setting it up, pushing one button, and going to go brush your teeth, or going to go DM your crush, or going to go do anything else, right? You come back after an hour or 30 minutes, and your model will tell you how smart it's gotten. And if we can see here, I'll showcase when we're doing it, is every step in which your model trains itself. It tells you, this is how smart I think I'm getting. When your model first starts out, it tells you, okay, you gave me a bunch of faces. I think I'm 20% accurate right now. Let me run another step. After the second step, I think I'm about 21% accurate. Not 21, can you do some for me, but 21% accurate, right? And then it keeps going on and on and on and on up until the point where you are confident with your accuracy. So your model runs as many times as you tell it to, and you define that in the code, which we'll do together later, right? And then after that, you go ahead and check. Okay, so I trained my model. Let me go and test it on images that were not part of the class. I just look for a bunch of random memes online and check to see how smart the model is. In this practical example, it wasn't too accurate. So it saw the picture of the baby. I don't know, what would you think that baby is? Confused, scared, shocked, fear, right? Most likely fear, and it said that it's sad. Yeah, the model classified and said that here's a picture of a baby. The actual class is fear or surprise, but I think it's sad. And now you as the human being will be able to decipher, my model is not doing so well. Let me go back and train it again. And you repeat the process over and over and over again until you can accurately classify the green gummy worms. Because if your model isn't so smart and you go and install it on your crush's phone that's visually impaired and you make her eat yellow gummy bears, I've got news for you, right? So you got it, yes? Yes.
So you're validating your human model, and you notice that it's not as accurate as you wanted. Does it mean you go back and use additional data, or you just use the same approach?
Good question. So the question is, if your model is not accurate, do you go and get new data? You fortunately don't have to. You just need to reconfigure your parameters. So if you use the specific, remember how we were looking at a bunch of predefined models earlier? If you use a model that's not too smart, you can just go ahead, use the same data, and change the predefined model, your checkpoint, your benchmark, let me call it that, right? Sometimes you can just say, okay, I can use the same images, but let me try and twist them a little bit. Maybe the 1,000 images I gave to my classifier were not good enough. Maybe it needs 5,000, but I can't go and get 5,000 more images. So let me just be smart and say, for every image I have, I'll rotate it by like 0.5 pixels, and that acts as a new image, right? Because if you showed a picture of a traffic light from a single angle, your model will be able to tell you that traffic light is a traffic light only if it's from a specific angle. But then you can take that same picture and just rotate it a little bit, put a little bit of lighting on it, Photoshop some clouds, right? That's how you're able to manipulate your data. You can use the same data, and TensorFlow allows you to manipulate your data. And that was one of the steps here. One of the steps here where you are standardizing your image data set. Yeah. So if your model is not smart, you just go back actually, and you repeat the steps from configure your data set for performance all the way to the second last point. So training is just going back in a circle over and over again until you are happy with the results. Okay.
Plus, just to add on what Yakubu is saying, that if you have a model, you don't have to keep on changing the parameters. There are tools that you can use called hyperparameter tuning. And then we can actually use a set space to set and get the best parameters for your model so that you don't have to keep on changing.
Absolutely. Thank you very much, Doctor. So those are some examples of the tools that you can use to actually to fix your model. Okay, so at this point, before we get into the practical example, how much time do I have?
5 minutes.
5 minutes. No questions. No, I wanted to dive into the practical example. Okay, so let's go ahead and share this window. Okay, so here is an example of a Google Colab interface that I put the code together, and it's as simple as just running it when you get the chance to, or if you have the chance to. So the first thing I did was collect all my images. I put them on a Google Drive, right? I was supposed to showcase some of those images. So I will go ahead and connect this. I'm going to connect one of Google's servers for me to actually run this training code, right? So after it's connected, the first thing I'll do is import libraries. And these are predefined for you. There's a TensorFlow library down there. You just choose to import the libraries that we will need. So with those libraries imported, once this block of code is done running, I'll be able to see a little checkbox underneath it. Okay, so that's done running. And then I went ahead and just created another class to simplify the process for you to say, I'm going to create this directories. And then I ran this block of code that helps me connect to my Google Drive where my training data set is, right? Alternatively, you can also upload your data set manually to Google Colab with a drag and drop, but that's usually not recommended because each time you reconnect to the data set, you have to keep uploading your data. So it's best if you have it on a Google Drive, and Google Colab can integrate with Google Drive to get your information, your data set. So I'm going to go ahead and connect to my Google Drive. Once that's done, this code just extracts my training information. So remember how I said I had my data as training and testing. So here we have the facial image data set, we have the training images, and then we have the different images, thousands of images for the angry people, people who are showing fear, happiness, neutral, sadness, and all sorts of. So there's my data set for training. I'm going to get my data set for testing. And then this is just for you. Now, these blocks of code, some of them are just little steps to follow for you to say that, okay, after you've done all these things, these are the 5 classes you'll have. And then I go ahead and give a display, the number of images we have in the training data set. In this example, is 28,000 images in total, right? I can't imagine taking a picture of 28,000 people. But luckily, someone on Kaggle did that and shared that with us. And then in the testing data set, we have 7,000 images. Then we go ahead and create the data set using TensorFlow's commands. These are just some of the parameters and hyperparameters the doctor was talking about. We have batch sizes, image heights, image width. These are predefined. You can read more information about them on the Colab notebook. We'll run through it together, split the data set into 80% and 20%. And then go ahead and proceed to identify our class names based on the folders we created here, so that your model knows that these are the only classes I need to work with: angry, fear, happy, neutral, sad. And the person who uploaded the image on Kaggle had a typo and surprise, but whenever I change that name, the code just breaks. So I just left it as it is. And then this is an example to showcase just to at what some of the images in your data set look like. So I'm going to run this code and it's showing us, right? Plotted. That's a happy face. That's a happy face, a happy face, maybe a face with fear, and so on and so forth. So this is just a peek into your data set for you to know that you're actually pulling the right information. Then you proceed to put your labels and the batches together. Again, these are the parameters that you spoke of earlier. And then you go ahead and tune it for performance. So basically, this is just using some sort of a buffer or a cache to say that this, obviously processing 28,000 images over and over again will take a lot of processing power, right? So let's put everything in a cache, or let's use a buffer to be able to not crash. So that's what this does. You can change the values a little bit, but predefined for us here. And then we go ahead and standardize the data and create our model using the model that you'd like to use, different classes like the ReLU activation. You can use the same, you can use sequential or 2D or 3D, whichever layer you'd like to use. These are just complex and I do not want to get into them, but this is just an example of it's pre-configured for us. Let's go ahead and run it. And then we compile the model using whichever model that you'd like to use. So you've got different optimizers, the SVD, you've got the categorical cross entropy, you've got the sparse categorical cross entropy, all that stuff, complex. I put them there so that you can maybe read up on them if you get a look at this collab. But right now, I'm just going to use the one at the bottom, the Atom optimizer. So once I run that, it gives me a summary of my model and says, hey, these are the parameters we have, right? Again, you don't have to worry too much about them. But once you have set your function and ran the callback, you can go ahead and set the number of times you'd like your model to train. Okay, let's say, for example, you want this to be trained 10 times. So you go ahead and run that. Remember how I said you run the process and then you can go do whatever you like. So say maybe, for example, you want to go spy on your neighbor or brush your teeth or go watch that episode of Netflix, right? So you run your training process and it's going to start. I'm just going to show you what it looks like on the first training step.
Sorry, Jen.
You're good?
That's gonna take a while.
Gonna take a while. Okay. So this is what the training process looks like. It just tells you for my first step, that's how long I have until I finish. 23 minutes is a lot. And that's my accuracy when I first started out. You can see the accuracy number is dwindling, right? It's fluctuating. So as you keep going on and on, by the 10th step, which is the number of times I said it should run, you'll get the accuracy value, which might be 40%, 20%, it depends, right? After you've done that, you can go ahead and visualize your training results using this block of code. It'll give you a nicely shaped graph that shows you how smart your algorithm was or your model was when you first started and when it finished training. And then after that, you can actually deploy it by creating a function that allows you to test it on unseen data. And this is where it was running on facial expressions. But you see, it's not too accurate, right? When I ran this before I came here, it said that this person is most likely neutral. That is not a neutral facial expression.
But it was because that person is black and your data has a lot of bias.
Oh, we're starting with the biases now.
Yes.
So there's other things to take into effect, bias and things like that. So then that's my model running and it's not too accurate. So what I had done actually was just got random pictures of Mark Zuckerberg. We're going to actually analyze his face. I know everyone thinks he's a lizard, he doesn't have facial expressions, but I got five different facial expressions for Mark. Can you believe it? I had to search high and low for it. We were going to analyze his face, but this data set will be available if you'd like to have a link to it or this entire Google collab. Just let me know. I'll share the link with you so that you can copy it to your Google Drive and tinker around with it if you need to. Thank you.
You can leave your code running. They will see the results displaying there as they are listening to the panel discussion. For those who have burning questions, Yakubu is going to be here over lunch. So make sure he doesn't have an opportunity to bite anything. Question in human until he can answer all your questions. That being said, let me allow you to take a seat. Thank you so much.
Thank you very much.
We appreciate the presentation. Okay, moving on. We are, I think, 20 minutes or 30 minutes behind now. So lunch is going to be cut short by 30 minutes also. Allow me to invite our panelists to a discussion entitled Towards an AI Strategy for Namibia, Creating an Enabling Environment for AI Advancement. So this builds up on the keynote speaker's speech in the morning. Dr. Shinapinda was speaking about AI and how we can build a policy framework for the nation. So to moderate this panel discussion, I have Professor Art Gamundani, who is an associate professor in cybersecurity within the Faculty of Computing and Informatics. And our panelists are going to be none other than Dr. Anabatros Gorosis, our executive director for DREAP. DREAP is the Department of Research Innovation, Directorate of Research, Innovation and Partnerships at NAST. And she so happens to be the host, and she owns the space. So we had to say, please, before we came here, Madam, may take a seat. All right, our next speaker is not a new face. You listened to him in the morning, and he was inspiring you to transform, and he promised data, and he promised many other things. I don't know what else he promised, but all I remember is it was automation and personalization. And I wondered, is it 5G era? I don't know what they are promising me, but yeah, our next panelist is Mr. Nawali Kando, the head of digital transformation and innovation at MTC. To join him is Ms. Kito Chilongo. And Ms. Kito Chilongo is a senior tech fellow from Mozilla Foundation. For some of us who have been here for a little while playing with technology, we grew with Mozilla, and I still prefer Mozilla as my browser. So I've been pushed out, and they put plugins and remove things for me. I can't even access my staff intranet properly, but I find a way around and I go back to Mozilla. I'm reporting myself, and they already know that I'm a culprit. So I'm so into Mozilla. Welcome, ma'am. Next on the panel is one stakeholder who ensures that my voice is loud and clear. So before I came here this morning, I had to get some immune boosters, and these immune boosters are paid for. They're really paid for. I don't know, or I pay for myself. But yeah, someone pretends to be paying for them, and that is none other than Met Health. And to represent Met Health, I have Ms. Gome. She is the Executive Information Systems Officer at Met Health. Welcome, Madam. So now let me allow the capable moderator, Professor Atli Mnyarati Gamudani, the non-original AMG, according to someone.
We can actually have a panel discussion about that AMG story.
Yes, I think it should.
Okay, it's a great honor. I'm really not impressed that time has been eaten, because this is a very exciting panel discussion. And I thought we were going to have almost like the whole day for this. Without taking much time, is the working title that is going to guide us in this session towards an IA strategy for Namibia, creating an enabling environment for AI advancement. The approach that you're going to use in this panel discussion, so that at least we try to cover a bit of mileage. I only have one set of questions for each panelist, which they are going to respond to, and the other panelists would also maybe give their reflections based on that. I'm not going to follow any order in terms of how the MC has introduced my panelists. Do not ask me the order that I'm using. I'm just trying to find a bit of an entry into this whole discussion, and would open the floor later on. Without taking much time, allow me to introduce the first question and my panelists for that. Ms. Hangome. Yes, as an executive, information systems at Met Health, I like the question whether we are the ones paying for our medical aid. Okay, that's not the question. Could you share your vision for integrating AI into Namibia's national strategy and the key infrastructure requirements needed to support AI advancement, and how that translates to your industry?
Good morning, everyone. Thank you, Prof, for that question. So to start off first, maybe let me just introduce myself as someone who's very passionate about talent, and more so local talent. And really just making sure that we harness the talent that we have within the country, and especially with regards to emerging technologies. So how do you, can I stand? I'm feeling a bit awkward, the chairs are a bit low.
It's okay.
Never mind. So how I see the vision of AI going forward within the country. I think there were a lot of good points mentioned earlier this morning. And the one I think that most of us kind of always have a question in our back, in the back of our mind is that what happens to the human? Where is the human being in all this? And there was a question to say, are there any NGOs or any of those representatives in the room earlier? I'm not sure, but we need to see more of those present at these discussions. But just in terms of the infrastructure that is needed for policy as such, which is very important, I think we must really just appreciate the importance of such developments because it really does impact the human beings. So number one, for me, it's really the humans. And where does it start? It starts at so that we have inclusivity is also one of the words mentioned, that was mentioned earlier, that we should not leave anybody behind on this digital bus. When you think of people in the remote areas that do not always have the information, they should not be left behind either with regards to the digital services. So that's where it starts. How do we empower ourselves to be more knowledgeable? And I think when I was also a student here, and my first class in programming, I literally thought my mind was going to explode because I had no idea of the concept. And that was more than how many years ago? Maybe 15 years ago. I had no idea. Now, children that were better exposed actually, had some ideas so they could, but somebody who is coming from a background where they had no exposure at all, it's like really foreign. So we should not include them. So it starts at that level where, even at primary level, that we only introduce these in the curriculums. I'm not sure, colleagues, are you speaking to Ministry of Education to introduce this at the lower, levels already as the children grow. Secondary, just have some introduction. I know that the private schools are doing quite, some work in terms of introducing this, but then it should start much earlier. And then obviously so that we can then have the people to do the work. Okay, that's one. So the capacity building from the early stages is quite important with him. And then there was also another interesting concept that was mentioned. Guys, we need to take this seriously. If you do not stand up for Namibia, somebody from outside will come and give you a solution. So we need to own our solutions here in Namibia. There's something in the financial sector where they actually limit investments, where they say, okay, have 45% of the investments that are done must be localized. So that actually helps to grow, local players in terms of that you can invest. So that's in the financial sector. And then the 55, you can invest wherever you want to invest. So I think we could have something like that to say that in terms of technologies, let us put a limit to say that 50% should be Namibian, localized solutions. And then we can then shop around for whatever we want outside. I think that's the only way that we will be able to protect us because they are bullish. I mean, Microsoft is all over the show and nobody's competing against Microsoft any longer. I mean, apart from. So we need to guard ourselves against those bullish behaviors of those that are more advanced. And it doesn't mean that we are not able to come up with solutions of our own, for our own people, for our own markets, because we are the ones who knows best. Otherwise, you have a Mark Zuckerberg coming to tell you, no, this is what you need as a Namibian, which is wrong. So guys, please don't see yourselves as somebody who will not be able to impact. You have that in your hand. You have that power to impact this nation because we're looking for the solutions. We don't only need people that are partying all the time, we need solutions, guys. And it's for now and for the future. And lastly, within the healthcare space, this is actually a very interesting space that we are in, because I know with the financial sector, they started a while back. And along with any other sector, we're also now moving on to the digital transformation bus. So ideally what you want, or the strategy or the idea that you have is that let me just backtrack a bit. So I spoke about capacity building, which is the foundation. The next would be then the networks, which are already, advanced. But then also in that is that we need electricity for you to be able to power your device. Because as much as you want to have your phone operating, you also need electricity. So ideally, those stakeholders should also be involved. But we also have a lot of sun in Namibia. So we can't say we don't have the resources available. It's just for us to make use. So those are some of the players that are needed in the strategy to take partnership. Within the healthcare space, very exciting industry. I think the analogy that I can give is that you are somewhere, and I know that there are also people in the space. I'm not sure, Mr. Maruasa. There's quite a lot happening within the provision of health services to remote regions, where you would take your phone, connect to an app. Obviously, you need to have network. So the service providers, the network service providers are making sure. But then you'll be able then to, let's say you have a snake bite, or you fell and you were broken, or something happened to you and you need medical services. You will then be able to get your phone, get on an app, get in consultation with a health provider that will be able to give you certain advice that you should just be able to assist you in the meantime. Or even if it's not that critical, that you can get your full services from your phone, and you get your medicine, sent to you via drone or whatever to be delivered to the remote area that you are in. So that's ideally where, what the vision that we have in terms of provision of health services to everybody within the country, whether you are in a remote area or whether you are that it should be very easy for you to access health services from wherever you are. Whether you are a farmer, especially even because now driving 400 km just to go see a doctor and back, you can do that from your phone and then still be able to get all the services that you need. So ideally, that's really the vision and the future going forward. And obviously with all the different partnerships to play along with what needs to be done. Thank you.
Thank you, Mr. Ngobe, for bringing up some of these insights and creating a vision for us to start also looking around that. Now, I'm just giving half a minute to the other panelists just to reflect on what you've been saying. I'll just go in this order. Please don't wait for me to take the mic. Just pass it on after your half a minute. Over to you.
Thank you. Hi, everyone. I loved your intervention. I agree 100% with everything you said. Perhaps just, I think maybe the terminology and bring everyone onto the same page. You spoke about, human agency. That is one of the principles of Mozilla, promoting human agency. Like humans are always at the center of any technology that we build. Our values as humans should be, imprinted in these technologies. You also spoke about, like humans as well, like the importance of us, having over these technologies when things go wrong, who is accountable and so forth. Localization is so important, and I'm glad that you brought that up. And yes, big tech is they are British. They have central, they deploy tactics that make it very difficult for, small players to enter the market, innovation outside of, the US and China and Europe. So yes, localization, but also, and I think the other thing about big tech companies is that we need to know, and I love that you had someone else, the previous speaker talking about training data and how to, come up with these models, because they purposefully do not, explain how the models work. And they do that because they don't want to be accountable when there's harm. So we're just like, okay, whatever. It doesn't work on Black people. It's because it doesn't work on Black people. But it's there are some sort of values like that are imprinted in those technologies. So that's what I wanted to say. Thank you.
Thank you. Quite brilliant points. I think narrowing in on the localization part, I think it's critical that we localize the solutions we create in the country, because it will bring us to a point where we're really able to contextualize our solutions. Most of the time we adopt, technologies that actually don't speak with our needs. But we possibly just do that because we want to play catch up with other countries. But if you look at localizing from a technology perspective, I think that's quite great. One thing that should be coupled with that, and we touched on it as well, was then the skills. And I think at grassroots level, from when kids start learning, it's quite important that we even look at from a curriculum point of view, what are the government initiatives to ensure that we have digital skills and digital literacy embedded within our curriculum? Because at the moment now, like you mentioned, yes, you will find it more in the private, that they do have robotics, all of these different courses, but it's important that within the public sector as well, the public education system, we start bringing in these skill sets. At the end of the day, we want to move towards localizing skills and all of that, bringing in technology. We have to start by actually teaching technologies to the young kids and everything. It's quite important. Maybe another thing to add is, we look at who are the individuals who are entrusted to also bring about these skill sets within the young individuals. You'll see that in most of our education systems, that even the teachers themselves need to be taught how to utilize digital technologies in order to facilitate this learning environment. So I think it's quite critical from a strategic point of view at a national level. We start embedding digital skills and digital literacy, not just from a curriculum point of view, but also looking at the teachers and all of that. So that also then goes into the whole, whether it's what you call it, universities when they train the teachers and all of that. So it's a whole ecosystem that we need to look at. Another thing as well, just to add, from a partnership perspective also, we're not really operating, we shouldn't operate in silos. We have the health industry, the communication industry, the academic industry, we have all of these different industries. And I think there has to be that interplay between all of these in order for us to actually start driving our objectives or driving our value creating activities to a national objective, which is creating a proper AI landscape. Thank you.
Thank you very much, Professor, Facilitator. So from an academic perspective, I would just maybe, Ms. Mambushe, I would just like to maybe spread it around. Yes, I agree, the health space is quite exciting. The e-health space is even more exciting. And my question is, I know I'm not asking a question, I must reflect, but it is, what is it that we're waiting for? I was now just trying to go through my book and looking for a company, because maybe a month or two ago, I was in Germany and we went to visit a company that's already doing the drones. They're already doing the e-medicine delivery to spaces. It's already here. And you're saying let Microsoft not dictate and so on. But we know this since 2 years ago, that's already there. So what is it that we are waiting for? Why are we not there? I just wanted to be very provocative to say, We know all of this. So what is it that is limiting us to have already started to pilot some of these? So we've already started conversations with MTC and saying, look, let's look at the drone technology space and let's enter the e-health space and see, because we need to understand our local context, rightfully so, in Namibia. So I threw in Germany purposefully because doing that, the technology there is so much more easier, I would say. And I'm not an expert here, my experts, but we are talking rural environments. We're talking long distances. So what stops us from looking at the technology out there, adapting it and testing it and running with it? I'm talking from a university's perspective. To ask me the same question, ask MTC the same question. You ask all of us the same question, and we're sitting here with the information, with knowledge, with the experts, by the way, and we are not there. We're just leaving it out there.
You can tell your neighbor the Indaba is started. Tell neighbor Indaba is started. Right. I like the provocative questions that are now popping up from the first question that Ms. Angombe helped us to have some reflections and visions. Now, allow us to take this discussion further. I want us to bring in the next question for us to be guided further in this whole discussion. I call upon Mr. Nawa, and we are asking this question to say, can you just shed a bit more light with your experience in the digital transformation? How do you see AI playing a crucial role in the development of Namibia's telecommunication sector, and what opportunities and challenges do you foresee? So then we can build on that. I know the audience is now eager to ask questions, but let's take this, we do another round, then we can also go to our audience.
Thank you so much for that question. I think I'm just going to labor on one main point. I think what is the expectation from anyone here in the room from an entity like MTC? Customer service, good customer service. You pay for a service, you want that service delivered, you want it delivered efficient, you want it delivered in the best way, and you want it delivered at the best price. So when we speak about artificial intelligence, and I touched a little bit on it before, was how can we leverage AI to bring about a better customer experience for every subscriber that we currently have. And part of that in our strategy, what we looked at was, so there are key emerging technologies out there. And from a telco perspective, we need to reinvent ourselves. We need to look at how we can start utilizing our data insights much more better. So at some stage in the telecommunications world, the big thing was big data, big data, big data, big data. And a lot of telecommunications entities started investing heavily in data infrastructure. From an MTC perspective, we put in millions and millions in terms of bringing in enterprise data warehouses. We spent a lot in terms of bringing the cloud infrastructure as well. And then came the AI wave. And with AI, it's like, oh, now it's, you can leverage different machine learning models to actually come about or to bring about use cases that will benefit your customers. Whereas before we'd have data analysts just focus on business intelligence, reporting, and all of that based on what people request for. But now we're at a stage where we no longer want insights from an individual that is maybe tasked to create reports, but now we actually want the insights from the actual customer's activity, as an example. So the opportunities that we now find ourselves with is, okay, we're now able to improve upon things like network efficiency. Why? Because you are able to leverage on AI that is able to tell you, okay, which towers are off. Before we used to have people calling the call center, we'd have all of a sudden drop of sales in this area and whatnot, and people responding to that. But the question was always, why can't we leverage AI to bring about these insights and to bring in systems and processes that actually bring about those self-healing capabilities? So now you have machinery, you have infrastructure out there that's deployed, but it's able to self-heal itself because it's able to see, okay, based on these and these patterns, we should trigger some sort of action as an example. That's in the network efficiency point of view. So things like network congestion and all of those different challenges that we currently have. I don't know, some of you go on holiday, whether it's in the north or whatever it is, and all of a sudden, because everyone is in the north, you're unable to call, you're unable to text, you're unable to do data and stuff like that. But how do we utilize AI to start giving us those proper insights and bringing about the necessary interventions that our leaders can actually take decisions based on in terms of how we then deploy our infrastructure around there. I'll give another example. Might even get in trouble for this one, but we spent $1 billion rolling out network towers to areas that are not that do not have adequate infrastructure. And that was a directive by government to say that, you know what, let's bring about let's bridge the digital divide. Now we put in money, we put towers in areas, and you know how some villages are. You put a tower there, okay, the tower is there, but next thing, that entire village migrates to another area, as an example. And the question is, but how can AI actually help us in decisions that we are able to collaborate with policymakers to say that, you know what, these areas do not need infrastructure. It might be underserved, yes, but if you look at from a global perspective, looking at all the different stakeholders, you'll be able to know that, no, this is a village, these people migrate, these people actually, you know, you won't find them here in a year or so, just as an example. I'm just being very practical. Another one is, if you look at our customer experience, about 3 years ago, we introduced chatbots to alleviate the challenges that our customer service operators were facing in the call centers, for example. So you'd have a lot of people calling in for the same type of queries. And these are queries that they have a script to answer. So the question was, bring in AI and make it easier for a user to just conversate with them on WhatsApp or on the web and actually get answers. And these are very simple things because the information is there. So the question is, if we have a knowledge repository of whether it's insights, whether it's frequently asked questions, we can leverage those, we can utilize those questions and train these different models. And funny thing is, if you go into our call center, you will find there's a group of people actually answering calls. But then there's also a group of people who are training these chatbots on certain questions that come through. I'm not too sure if any one of you guys have ever used our chatbots. Please do feedback as well. Another one is then the predictive maintenance. Currently, our maintenance operations are very much reactive. When something breaks, we fix. Now I want to move towards being able to predict, I see that this machine is going to fail. Why? Because the calls are going high and it's this period, it's this season, stuff like that. Those are the opportunities that we actually have in terms of utilizing AI. From a network security point of view, cyber security, we're able to detect anomalies and all of that. So we're trying to utilize AI to bring in those capabilities. To round off, I'll go into the challenges. I think Ms. Anna spoke to it, Ms. Sangome. She spoke about things like electricity, for example. So there's a lot of base or very basic infrastructure that we need from electricity to whether it's sanitation, just stuff like that, that actually needs to be rolled out in order for us to actually have the right base to then bring in the telecommunications infrastructure. We can talk about cloud solutions, but a cloud solution requires electricity. I don't know if you have seen the plans, what's happening in South Africa. Right now, we are, as an organization, we are planning around how does MTC the resilience in terms of power, because now if you see NamPower is going to be doing load shedding and all of that. So we're talking about AI and how brilliant AI is, but if there's no electricity, there's no AI. It's an example. You look at the underlying infrastructure as well. Another point is then also just cost and return on investment. We talk AI, what does AI need? It needs data, right? And you need the more effective you want your models to be, the more data you need, the more training it has to undergo. So this means you need a plethora of data you need, and to house this data, you need infrastructure, cloud infrastructure, data infrastructure. And this obviously then drives the costs in terms of how much we have to invest in to ensure that we have the right infrastructure. Those are the challenges we face. and to constantly have engagements with government to understand, okay, fine, if we want to have a proper environment, this is the infrastructure we need. This is how much we need to invest in, but also the infrastructure we get most of the time, it's infrastructure from outside. So to bring in this infrastructure as well, there's taxation, there's all of that stuff. I think there's someone from NAMRA here. So the question is, if my man, if you have all of this infrastructure coming into the country, but this infrastructure is labeled as luxury goods, as an example, with tax on that basis as well. So there's a whole ecosystem and a whole approach that we need to take in to look at how do we address these challenges. Thank you.
Thank you, Mr. Nawa. I think we touched on very serious teething issues around some of the aspects, especially to realize some of the benefits. I'm checking the time because we are standing in between you and lunch, and I know it's not a good position. But instead of giving to my panelists right now, I want to take just two burning questions from the audience. So that at least I can just make sure that I'm still with you. Two, one, and at the back. Okay, I'll come then.
Okay, good afternoon. Very interesting discussion. I think this whole morning has been very interesting. I'm even thinking we need Sarfire 2.0. And I had a question which is building on what Anna Matros said. And I'm leaning towards provocation. So as a UNESCO, we are supporting the government in terms of the development goals. And the development goals are digital transformation, yada, yada, yada. And as mentioned, this room has the youth. It has the expertise. I will not say elders. It has the expertise. It has the people, and it still has some people with the resources. We are just missing the government component. So from the United Nations point of view, can we hear solutions? Because I've been hearing a lot of challenges pointed out. So if we had to come to the table, how can we help you to move towards this AI strategy? And for instance, what is stopping NAST and UNAM from ensuring localized content, training data for AI? And that is, from my UN hand, I'm thinking that's a concept note away. Thank you.
I can just run to the fact. Of course, I'm hearing localization, local is local.
Thank you for the platform. I just have one question on what the organizations like MTC, maybe accelerator labs for perhaps students or entrepreneurs to come up with where they can sort of like, put ideas together and build things going forward so that we can, when you have people building together, you can also sort of keep them, like you learn from each other, things like that. So I thought maybe perhaps there are programs or, spaces where organizations put up, set them up, because coming up with this the kind of technology might be difficult to run in terms of the infrastructures. So you sort of might need the big players like now MTC, UNESCO, and creating spaces for young people who's that are interested in these kind of things, and they can come together and do things for Namibia, rather than just having individuals or perhaps I don't know. But otherwise, just perhaps if there are programs, or maybe there are, in case, so to say, plans to come up with this kind of programs. Thank you.
Thank you. That's a question from Joseph. Sorry. So I have the AMG now. Those questions were more or less directed to you. I'll give you the mic, Mr. Nawa, so that when she gets the mic, I wanted to take a question. And the following session, yeah.
Okay, just to briefly answer, I don't know, my man from behind there, so Joseph, Mr. Joseph. So we have the MTC Innovation Center here not too sure if you have been given a tour, but we were trying to really have a lot of engagement sessions with the student communities, various communities, to highlight what does the support that MTC is able to provide for the MTC Innovation Center. But ultimately, in terms of the activities that you're looking to do in terms of whatever innovations you're trying to come up with, ideally that's a space. Feel free to reach us. You will find us here. Even, DRIP on the 6th floor, you can reach out to them and they will give you the necessary guidelines on how to get through to us. But to add on that as well, we have been on a partnership drive with various entities beyond just MTC and NAST, because we do know that there's a component of incubation support that is required. So through the NBII as well, that's a platform that is available and it's on campus here. If you look at the recent players like the CC Hubs, you have the base camps, all of those different entities, Impact Tank and all of them. We are creating a community here at the HTTPS where we have all of those capabilities to support the different entrepreneurs and the innovators that are really working on impact solutions. So please feel free to reach out to us where we can support. I'll give over in terms of Madam from UNESCO asked a very loaded question. So I'm going to be very smart to divert it to the other contribution.
Okay. So that at least I don't keep on exchanging the mic, you're going to respond to the questions and you jump onto your question, which is saying, as an executive director for the Directorate of Research, Innovation and Partnership at NAST, what steps can academic institutions take to foster AI research and education in Namibia, and how can academia contribute to developing a skilled AI workforce? So first priority, the audience questions, will take mine.
I think the question is exactly what it is. So I think there was some AI thinking telepathy going on. So thanks for that. And let me just say that this whole morning and the IndabaX is coming at a very ideal time where we are looking at, and we know that we are in this era which is dominated by AI, and it fundamentally shifts everything. AI, the impact on society is 100 times, 1,000 times bigger than your PC time or when internet came on board, or cryptocurrencies in the space right now. So it really challenges us as higher education institutions to on our basic assumption of technology in general. So having said that, we are facing this daunting task to educate our young minds on the relationship between man and machine. That's it. And also in a space where, and I'm sure it has been discussed, where the machine somehow is being perceived as it's no longer just a tool to help the humans, it's actually replacing the humans. And this has been the discussion, and as a higher education institution, so what are we doing about that? And what we are saying is this is a fantastic opportunity. We are not here to scare people and threaten them to say, AI is replacing this. And I think Mr. Likando also indicated some of the positives around that. And I think that is the narrative we should be taking on to say, fundamentally, we understand that every capacity that we are having is being replaced, or it's looking at efficiency and increasing that. But that's an opportunity for us, at least in the higher education space, because we know this and we've been seeing it coming a long way, and it's really just taking effect now. And the challenge I think that we have right now is that it's moving very fast. It's accelerating, and we need to keep up with the pace. And so for us, it is exciting in the space that we are looking at how do we educate now our young minds and take it further, because we need to show them the light at the end of the tunnel. That's what we do, to educate them and to take it further. And then we have this interesting thing that just also came up with it, and it's the Chat GPT. How many of you have started working on it? Hands up, just. And when it came, the first thing it came, we were like, no, we need a policy. We need to tell the student, don't use it, use your mind, don't. And so it really created a disruptive effect everywhere. In schools, we're like, oh my goodness, now the kids can't think for themselves anymore. And it is human nature, you know, you go on that other end. But for us here, we're looking at it from a really positive perspective to say that we are in this position to educate and to teach our students how do we use technology to coexist. So for us, the challenge is to reskill and repurpose what we're doing and really, because now we know what is out there. We already saw, you know, facial recognitions, everything. Those things have been in the space for a long time. So we need to now take it to the next step. Coming to your question. So what are we doing about it? We've introduced High-Tech Transfer Plaza Select, also maybe a little bit late, because it really comes after we have really, all of us now have this understanding of we are in this space. The time is now. So the president of the country is asking, what are you guys doing to educate the nation, to get the nation ready for that community 5.0? There's lots of disruptive technology out there, technology transfer, the tools that are out there. So we are literally just saying, we are introducing spaces like High-Tech Transfer Plaza Select to create a technologically inspired ecosystem where we are saying there's no longer time for industry colleagues to be operating on their own. It's university industry interaction that we need to focus on, and we need to say, what are the challenges out there? How can we help? And we create this space where we have students, experts, entrepreneurs coming together and saying, let's work on this collectively. And I'm so happy you're asking, how can we help you to get to whatever it is that you need to do, to get to the e-health space, you know, to get to this space where we are really proactive in getting proactive to get Namibia on the map. So I said previously that the time is now. Africa, this is our time to shine, and we can really create, and we've seen it, create technologies that work for us here. So we have, we've started at NUST, for example, started with science and technology parks, establishment where we are looking at specific areas and economy spaces where we can make a difference. As a university, we have three things. The purpose why we exist. It's impact, it's relevance, and recognition. If we are able to make the societal impact on how we teach our students, and we as NUST, we are obviously gearing ourselves to educate for jobs that don't exist yet. And this is the space exactly. So if we can get that impact out there and manage the societal impact or the fear, I think this is where we are right now. We automatically go to policies that need to be in place to govern a particular situation. Instead of testing the space, go out there, create the sandboxes, and this is HTTPS. We are encouraging industry to come and say, test your products, it's more cost efficient to come and test the product out here. We've got our students, we've got our experts. Don't go to the market without understanding what is the customer experience that is needed or what is required. So it is a testing ground all over. We need to be proactive, dynamic. The policy must adapt to the changes that are there. And it can't be a regulatory approach, for example. So, Mr. Facilitator, coming back to your last question, maybe just in terms of you want to hear solutions also from the audience. So we're looking at creating these innovation hubs, the science technology parks, but what we really need is investment. to address some of these elements. So how can you help us? We can discuss dedicated funding that is really geared towards implementing this technology strategy or the AI strategy that we're talking about. Because without that, we are not able to and there's so much that needs to be in place for us to teach our not the children, our students basically. We have a Fab Lab that looks at product development, and every day they are we are saying our basic needs here are not yet met. Our students are struggling with laptops, iPads, things that the students or scholars in schools are already having to further their education. So we are at the basic blocks. So we need to be able to move from that point. So really, I hear NAMRA is here. So we are talking about tax levies, for example, maybe that can be invested or directed specifically for research and innovation development. To put the basic infrastructure in place, and then only we're talking about the students, every student having a 3D print at home, just testing around, playing around, that kind of space that we want to be in. So I think overall, that is what I can say in terms of what we do to create a conducive environment for capacity development within the AI space.
Thank you, Dr. Aaron. Getting back to the vision that Ms. Women started off with, maybe I just give it some half a minute to reflect as we're jumping with our time, then I'll come to Ms. Shilong.
Thank you. The doctor just mentioned exactly what needs to be done. With all these nice dreams, unfortunately, we cannot do it without money. So, funding is very important. First of all, even I think as students, you may have, your brilliant ideas, but if there is no support in terms of financial support, an idea just remains an idea and does not go to the next stage of seeing a day of light. So funding is very important, and I think that is definitely an area that we need to look into. To fund all these great ideas, and I'm sure there are also available options that are available at the moment. So sometimes it's also just a matter of awareness, being aware of what is where, and there are also ministries doing things, but then sometimes we're also not aware of what does Ministry of Trade, for example, have in terms of support, financial support. So I think we also just need to have that awareness.
Okay, I see a hand flickering from the audience. I think it's a burning question. I didn't want to go to the audience now, but Ms. Shilongo, I'm going to come back to you and give you a question as well. You will reflect, then I'll give you a question.
Right, sorry about that. So I think that's more just a question directed to academia and NUST as well. I am a former student of NUST. I'm a product of NUST, product. I was also a student leader here, and I think so. I'm always for the students ultimately. So my question is just more in terms of, number one, coming from the Faculty of Engineering, right? We have brilliant research projects every year that go out, students come up with projects, their prototypes, you have to prove it and you have to test it. And it goes through all these things, but it's more just how are we transitioning those research projects into commercialized business? How are we taking those types of scenarios as well, in addition to what we have here, and also helping students and grooming them? And then the other aspect I just want to touch on as well is in terms of me as a student coming to these types of spaces, what guarantee do I have in terms of intellectual property protection? How am I safeguarded that my innovation will not just be, and sorry to say, sometimes industry, we're sharks in the police. So, we'll take your idea, it has a lot of potential for returns on investment, So how are we safeguarding our students and those, these types of innovative platforms as well? And So that's just my question.
Thank you. Now I'm conflicted because you're hitting the right spots. PMG, this is questions for you actually.
I will not take much of the time to give you your space, but that's a very good question, and it's actually very timely because we are right now in this space where we are more cognizant of innovation. And so our directorate is responsible to set up the technology transfer office. That office is then to help protect the intellectual property of our students and our staff members. And so it is really a crucial issue to institutionalize some of the ideas of the students that come out of it, so that we are able then, and Mr. Nawa is eloquently stated that we are able to support our students and our staff throughout the entire research innovation value chain. So that we are able to, some of the ideas that have already come up, and you said there's already a big repository of ideas sitting there. What are we doing about it? And so what we are now doing is looking at that and looking at the potential of commercialization thereof, so that we are then able to facilitate the process through our various instruments that already exist. The Namibia Business Innovation Institute, and also we have started with accelerator programs. We are in conversation with our UN partners that already is running the accelerator lab, innovation lab. So we are looking at all of those elements, and we are looking at how do we get the idea to the marketplace. And that's where we are in close contact also with our partners. And we are very fortunate to have MTC as a partner in this particular space as well, because they are already ahead of us. And they are also looking at gamification, where the scholars from schools are coming and their ideas of how to create games, for example, and then we are able then to protect it in that space. So I think that's good. Just the last point to add on to another something that we need to look at is creating the innovative culture. And if once we are into that space of creating the culture, I think it is easier for us to not be fearful of somebody's going to steal my idea. And that is a space that we need to create in the university for students to come and feel free to express their ideas, knowing that their ideas may go on the commercialization route, just to mention.
Thank you for that. Giving the floor now to Ms. Shilongo. You're going to find time to also do the reflection on either of these questions or what was discussed before. But I would also want you to maybe touch or give us some insights on, given the background that Mozilla has been at the forefront of promoting trust with AI, how can collaboration between different stakeholders, including government, industry, and civil society, be fostered to create an inclusive and accountable AI strategy for Namibia? Over to you.
Thank you very much. I feel like that's a huge responsibility. Just to reflect maybe on points that were mentioned. I know MTC is very much about permissionless innovation, and I'm here to say that maybe another the doctor also mentioned, promoting innovation and this being pushed, not only like being calling for regulation, but I think that given the harms and given the magnitude of AI and the kind of the risks that it poses, I think that we should have a precautionary approach to innovation, which first of all not only assumes that we need to see the harm first before we act, but that we incorporate principles of protecting people, you mentioned people migrating and moving away. So many things to ask about that, like why, how did you approach those communities you talked to? Why are they displaced? Why are they moving away? Those are all, what do those towers do to the environment and to how we live as communities? So many things. But to touch on your question, one thing that Mozilla has been trying to do for the past since 2020 is promoting the concept of trustworthy AI. And I think UNESCO has a similar concept. They call it responsible AI, but it has the same values. And we define it as having two principles. One, accountability. And the second one is agency. What do we mean by accountability? Accountability is that people who build technology, whether you are Meta, Google, Mozilla, Firefox, that you are accountable for the harm that you cause to whether it's environment or communities, people, individuals, or as a collective. You should be held accountable for it. If your systems go wrong, we've seen an example of that now. Who do we go to? Who do we talk to? What mechanisms are in place to ensure that redress happens, for instance? That's accountability. And agency is what Ms. Anna just was speaking about. That we build respect, first of all, into like the technologies that we are developing, ensure that they have privacy, data, technology itself, like AI, is based on data that is collected from people. And Mr. Nawa mentioned about how the business model had changed. It's no longer about like business insights. It's more like the customer. So it's a thing of mining data from people. So that means that we should the business model as well, not only like ensuring that assuming that customers just need a good product. It's also like customers need privacy, right? Customers need security. Customers need a promise that their data will not be shared with people who will cause them harm. Customers need to be assured that they, that whatever you do, when you're collecting data, it's the well-being of humans. And another thing that is very important is that because of how pervasive data artificial intelligence is that we ensure that there's better user control. And what that means is explainability. It doesn't mean that people need to be computer scientists. It is that that the decision that is made by a certain program was made by an algorithm. It was trained on data. People should know that. Also, transparency of being like, hey, this is how we got the data. Where did you get your data from? We've seen that we don't have data from Namibia, where people should know that this data was trained on a certain data collected from a certain area. And so that is what Mozilla is trying to promote. And this promoting trustworthy AI doesn't come from nowhere. Mozilla has worked with technology. It has changed the way that the internet has operated. I mean, at first, when search engines came about, people were very much about like search engine optimization, they were about profits. And then Mozilla came in and said, Firefox has been like, hey, people should be able to browse the internet with privacy. And that's why I'm saying precautionary innovation, because just assuming that, tech is good, just because you have good intentions is not good enough. And so we have, Mozilla has identified challenges, and one of them is data privacy and governance. And right now we don't have a data protection bill. We have an example of a certain company, I will not mention it, that defied, regulation or regulation instructions from a regulator within the country. And what does that say about when data privacy? What do they do with our data? Another is bias and discrimination, and I've spoken about this. Technology is bias. Technology is it has the values that people have. So if you see Black women as not smart enough, you will build technologies that kind of in a way do not see Black women as smart enough, or Black people as people, so to say. So we need to. That's a challenge that is that we've identified. Another thing is accountability and transparency. I've mentioned that. And it's not only about like telling people you should know the technology. It's about if you know, you're able to put up the mechanisms so that people, when they are harmed by certain technology, they know where to go for this, to say that, hey, this is not working for us, or this is causing us harm in this way. Another one is industry norms. I think this is very important, especially for Namibia, and we have a very small country, and I think we have kind of space to change the kind of industry standards that we have. So in prioritizing privacy, in prioritizing data protection, in prioritizing skills development, how are we, what kind of standards or what kind of industry standards are we adapting? And if we are going to, take the route that Uber has taken, be very opaque about how they operate, infiltrating markets and basically like taking jobs away from people and not caring about disrupting existing industries, I think we are in the position to take a different approach and set up different norms that will set people and create jobs that are meaningful. It doesn't make sense that, as Uber, the people who drive are the ones who get the least cut, Another one is, and it's very important, and I think everyone here has touched on it, is digital inclusion. And this is very important for Africa and the global South in general. The Minister of ICT, or the Deputy Minister of ICT, the other day mentioned that 49% of Namibians do not have access to the internet. That is very worrisome. That is very, very worrisome. And if we're going to talk about the fourth industrial revolution, we're going to talk about AI, we're going to talk about machine learning, that is worrisome. We're going to talk about skills. That is something that should be concerning to us. And then centralization and monopoly is also another challenge, and that's why we want this, trustworthy AI, because big tech companies such as Google, Microsoft, whatever, they stifle innovation in countries like ours. We don't have access to data sets. We don't browse have the luxury of browsing the internet in our languages, for instance. That causes a lot of exclusion, but also like it's promoting monopoly from a big tech companies. And so those are the challenges that we have identified, and that was this drive for trustworthy AI. And I want to say it's not only like identifying challenges. Mozilla has actually just launched Mozilla AI, which is a venture company that is investing in AI companies. One of them, and I would advise all of you, if you're interested, to look up Lelapa AI, and it's looking at collecting data for languages, so language models, so that people are able to use the internet in our local language, in our accents. I was in Cape Town just a few weeks ago, and it was surprising to see that the Uber driver had set their own the voiceover in an English accent that is Xhosa. Which is like because they can understand it. And that is the kind of things that we need. Sometimes people don't understand. I studied in Britain, and like the first few weeks I was like, I don't know how to speak English because I don't understand that accent. So I think it's, just accents, for instance, like capturing the way that we speak and being able to be on the internet as we are, like showing up as well. And another thing, that the doctor spoke about, and this is something that is maybe less, I think in Namibia, we think these things are less important. But innovation, it cannot be separated from imagination. And we don't have the imagination. Like, yes, we always talk about the economy, development and all of that. That's important, yes. But I think we have to innovate. You have to be imaginative. What kind of society do you want? What kind of values do you want to put in place? What kind of what do we want to do? Like, what do we envision in the health, in the education sector? We need to have an imagination to be able to do it. Yes, the economy is important, but the ideas won't come from the economy, unfortunately. And that is it. Thank you very much.
Right, I don't know how we're going to balance this because the time that has been allocated to us actually ran out of us. Let's consider this as a conversation starter into the lunch, so that at least we engage more on some of the aspects that have been highlighted by our panelists here. Like we have said, this is an Indaba, and Indaba doesn't just, let's say you start a conversation, you just end there, you continue. And you continue also explore different angles to the same conversation. So now that some of these issues have been brought to the fore, it's now time for us to start engaging in a more meaningful and deeper way as well, because they've really touched on a number of aspects, as you could tell if you're following through. I don't know if you're going to do justice, but I'm just going to say, maybe for the sake of progress, I'll just give them half a second. At least you are listening, that's good. Okay, half a minute to just give their last closing remarks. I'll start with from there, because I know some who actually restarted the whole panel discussion.
Thank you. Closing remarks from me, just very interesting conversations, and these are the conversations that we should be having. But then ideally, what we also want is that we want to feed back into the policy makers, the lawmakers. Very important, because they make law, they make policies, but then that does not remove the responsibility that we have to start already with what needs to be, as long as we do it ethically, and we do it with, obviously, with the love of our country and the love of our people, African, and for Africa, of course. And the nice thing about also, this does not, does not limit us to only operate in Namibia. We can operate, globally, because that then gives us more opportunities even outside the borders. So thank you.
I think in my closing remarks, I just want to say that, and maybe just finish up the remarks supposed to answer who are the stakeholders that we should be including. And I think everyone on this panel, first of all, has a responsibility to advancing trust in the country. I think we can operate from where you are, in the health sector, with telecommunications, but we all have the same objectives broadly, I think. I think the one thing maybe that we need to encourage is to bring in those voices that are usually not heard. So people who are, the health sector, I have a lot of qualms about the health sector in this country, but the health sector, women, how do they experience, putting into account the experiences of people and how they interact with your systems, for instance. So bringing people who aren't usually heard and hearing their experiences, I think will advance the kind of technologies and how that we introduce into our societies. That's very, very, very important.
Thank you. Okay. I'm trying to find the right words. I feel like we should look at why we're doing all of this. I think that it's very critical to understand why we're doing all of this. We're not trying to just implement technology. We're not trying to just do magical things and compare ourselves to the West. We're not playing catch up, but ultimately we're trying to benefit the Namibian, right? We're trying to benefit an ordinary Namibian. And at the end of the day, that requires a partnership across all different sectors, as mentioned, industry, academia, policymakers. And lastly, really, I think I'm not a believer of regulation. I believe in enablement. So I think from a regulatory or policy perspective, the focus should also be around how do we enable rather than how do we regulate. And that then will push us into a direction where we start creating those they call them regulatory sandboxes, because to be honest, or to be truthful, the pace at which technology is advancing versus the pace at which regulation is advancing, technology is far ahead. So it's very important. We can't be talking about regulating something that we do not fully understand. If we fully understood AI, I don't think we'll be having this right here. So it's quite important that we actually look at how do we collaborate, how do we work hand in hand, and really just have a very humble attitude towards how can we collaborate and create an enabling environment in order for technologies to ultimately benefit the ordinary Namibian.
AMG, can I use a request to be a bit funny here? Not funny still. We are 28 minutes into our lunch, so any minute that she's talking, we are subtracting from those 28 minutes because our keynote speakers are already online as well for 2 sharp. So you're going to have a less than 30 minutes lunch. So I just want to make you aware of that.
Okay. I will just say the future is Africa. The time for us is now, especially what we know for sure is that it is critical that any knowledge-based economy that we have, we should look at lessons learned from platforms like these and try to see how can we action it so that we lay the foundation for the youth to generate and derive the value from innovation. Because for us, our most critical price-worthy asset we have is our students, and they have the most innovative ideas. And I think for us, we need to just appreciate that such developments that we're talking about right here, AI, for example, it needs to take place amongst the reality that we face in Namibia: unemployment, poverty, inequality. So we need to really look at this, but I want to always bring the positive side of AI into the picture. And I will close off here, Mr. Facilitator, and just say, let's look at developing an impact literate mindset from where we are sitting, and let's celebrate the opportunity to make a difference. Thank you.
Thank you so much. I think we deserve even more of that round of applause. I just been given a very great idea by my namesake, Dr. AMG here. So the questions, we couldn't take them, but we're going to provide stickers. Let's fill these walls with those questions. They are very important to us, especially what you have been reflecting from this panel, insights, hints, etc., even the solutions to some of the problems that have been highlighted will be very much, you've been given the free will to actually fill this wall today with those questions. I just give back to Prof. Nishala.
Thank you so much. Of course, MG lunch is finished. There's no lunch because you took it all. I'm not going to keep you here because I know you're hungry, but you're going to promise me that you're walking back at 3 minutes to 2 o'clock. And by 2 o'clock, yes, settled and we are ready to go. So let's go grab our lunch. Enjoy it. Thank you, Professor.
All right.
That's why we're getting sticky notes from your office. I'm saying got permission to repeat.
I'll bring something.
You're not going to. And the
Let me grab my bag. Good job. Time management. It's always a nightmare. Want to get off the same. Let's hope that the delay that we experienced in the morning can stop this.
Yeah, this is the communication to yes. Okay.
And one of the prices is This is called this is IndabaX, the global. Yeah, just when I looked to the whole program.
People, let's go have lunch.
I don't think yeah, I know. Listen, I mean, the kids organize that.
No.
The cameras are.
No, it's that's first time you do you have a charger? Oh, I don't have a charger. My laptop died. Nice.
Thank you.
Very good session. I was just thinking, I wish you would have done something like this for South Africa.
We need SAF 5.2, 2.0.
Yeah, something like that. Yes.
Hello, sir.
How are you?
Hi, how are you?
I'm good.
I work with Commander at UNESCO.
Ah, nice. Welcome.
From us?
Yes.
Yes.
I think I am. This is
Actually, yes, yes. We were in South Africa together.
yes, that's true.
But then again. Yeah.
Ah, that's correct. Yeah.
The issue is the involvement for September as well. I don't know if Commander Coach, we're going to have a stakeholder engagement about the AI strategy. Yeah, I didn't know about this one.
Is it?
She told me this morning that I should come and share the program with me, and was like, yes, I need to be here.
Yeah, certainly, certainly. Which days are you working in August? Let me just take this plate. I think you need to put it there.
Something. Six.
Ano kutengeneza? Okay. No, okay. Oh, you are okay.
Are you not going to have lunch? No, I'm good. Okay. Sadly, I will just.
Oh, you're in it.
I just came to sit inside, huh? You'll be there struggling to look for.
What did our boss present? What did the boss present?
There's no presentation for him.
What just then?
It's right. He was just there, maybe just answering certain questions or something. Yeah, anything related to me. Like,
How many folks like $10?
yeah, I might just go back there. How many hours is that? Because I don't want to go back and struggling for parts. Oh, so you said you're getting the presentation.
Yeah. Because I saw the thing you were saying, and I went to go check my. Now, what type
Which thing?
The one you are saying when she nominated. Now, when yesterday,
Not email.
when she sent on Teams, when she sent me this yesterday.
Not sure. Email, huh? It's
Yeah.
not email. I remember Teams.
No, this was a personal
For you, it
invitation.
was email, huh?
No, that was a personal invitation. I saw the one you said on.
Oh, yeah, this one. You had to sign up, right? The one she said in Teams. You had to sign up.
But
Now, after you sign up, you will get this.
then she sent me the thing. and I
Yeah,
think she-
so this was for her.
I was like, no, can you represent me this?
So you didn't sign
I
up?
didn't
Huh?
sign up. Just come.
No. What do you mean on my ticket? I also just signed up. Then I think Pete was telling Nisha about it. And Nisha said it means a thing because like I think chicken was like I don't think the time. I want to take off my phone now. Oh, it's on the dot. Just want to be there. By 10 past.
That project was one point for now these guys, they went benefit. Now number is complaining. I'm no longer.
Complaining for no. Because they need to be given to right?
Not only that, the guy is saying, okay, I'm done. I want to move the production on you don't have seven. Now it's too hosted on
Oh. Well, I will leave you with my plate to take it with.
Yeah.
I'm just gonna go like this. Put it on
Remind
top
me,
of yours.
yeah.
Huh?
Remind me,
you.
ask me if I actually did my.
Which report?
I wanted him to find the thing. Because it would be better to take even how many people submitted after the deadline.
Okay.
What the best?
Go away, see you.
Yeah.
Like, just let me.
Yeah.
That's how you. You're not supposed to bring your food here. Where to be come?
No. My drink. The thing is the same. They were empty there in the media was. That's why we came.
You don't get
If I get charged, don't even go submit.
Papa Gula, how are you? Papa Gula. I'm using the wrong one.
Good afternoon. Propagula, are you online?
What happened?
We need to permissions to talk for them.
Which one? I commuted this one because he was.
Hello.
Yes, Prof, can you hear us?
Yes, I can hear you properly. So,
Okay.
so I should try to share my presentation.
Yes.
Can you see it, please?
Yes, we can see it. You can put it to presentation mode.
Okay, okay, I'll do that straight away. 1 minute.
Thank you.
Okay. Thanks.
Yes.
You can see me, you can hear me.
Yes, we can see your presentation. We can also see you perfect, yes.
Okay, okay. So can I go ahead or should I wait?
Just maybe just a few minutes. We'll start get a bit of a delay.
Okay, but please also, I would like to apologize in advance. I'm scheduled for a load shedding, but in case that this happens, there will be some kind of disruption of 1 minute, not 1 minute, just to switch on the mobile phone.
I hear you. Okay.
Okay, okay.
Noted. So Prof is indicating there might be a disruption because of load shedding.
What
For a minute or so. So
They already load shedding.
for a minute or so.
Okay, so wait for you to the transition.
Just only for a minute. In case that happens. All right.
May I have your mind? Okay. Nice meeting you, Mary. Can we all make it back to the main room? Or we will break our way after the first session? We are starting in the main room, please. Do make your way back.
That's what a VIP. Yeah. This one is. No, I'm just waiting for. So welcome back.
Our next session is going to start with Professor Bagula with his keynote address. Let me see if I can read his abstracts while we are settling in. So Professor Bagula is at the University of Western Cape, and is going to give a keynote address on artificial learning from machine learning to federated learning. The abstract reads, starting in the early 50s, artificial intelligence has been recently dominated by deep learning. We had in the early 50s, 1950s, for the 2K generation. So it has been recently dominated by deep learning, which emerged as a disrupting technology that brought forth many breakthroughs in the neurocomputing ecosystem. These breakthroughs are a result of its ability to analyze images, like we saw in the morning from Yakubu, videos and unstructured data in ways that traditional machine learning techniques have not been able to easily do. The neurocomputing has experienced tremendous growth from its onset, with milestones going from the 3-layered neural networks to deep learning, and thereafter expanding to transfer learning, federated learning, and more recently, split learning. It is therefore likely that in this space, a new X learning technique will emerge each decade from the ashes of its predecessor. With novel designs and improvements, each of the above milestones has brought forth new technical contributions with advantages and challenges in terms of security, complexity, deployment, and potential application domains. In this talk, Professor Bagula is going to start by covering these different milestones in terms of technologies, applications, and challenges. And thereafter, he's going to expand on a number of selective federated learning algorithms, a class of machine learning techniques that build on federated averaging algorithm to improve the performance of federated learning. Prof. Bagula, I believe we are now back and settled. The floor is yours.
Thank you very much, Chair, for giving me the opportunity to talk in front of this audience. Good afternoon, colleagues and students who are participating, even if remotely. So this afternoon, I'll be talking about artificial learning. with the objective of showing how all these neuro computing algorithms have evolved from traditional first generation machine learning to what I could call today X learning or federated learning. So the outline of my presentation is quite big, but because as you see it's presented here, it contains a lot of content. But in fact, I'll not talk about all these because I've been allocated 30 minutes, I assume, which means 25 minutes of talking and 5 minutes of questions. So, but anyway, what I'll cover today is part of a bigger presentation that I was preparing for other purposes. But what I'll be talking about, I'll cover today is artificial learning, talking about artificial learning a little bit. For putting things into perspective, I'll look at the artificial learning roadmap, how we evolved from the first generation of machine learning to what I call X learning. So I'll be talking about federated learning, which is quite important here because that is the topic that I've decided to dive into much more into detail. So we look at an implementation of selective federated learning and how these differ from the typical federated learning. And that's when I'll conclude with the topic itself. So let's talk about artificial learning. So what do I mean by artificial learning? Nowadays, if you look at everything that, when we are talking about learning model and algorithm, you find a lot of learning. We talk about reinforcement learning. We talk about machine learning, where people talk about transfer learning. People talk about federated learning that I'll be talking about expanding on today. And more recently, split learning. People also talk about ensemble learning. And I've been involved in a work on a hybrid learning with someone from the University of Namibia recently. So this learning, I mean, all these algorithms finishing with learning. So, and that's what I'm talking about when I'm saying artificial learning. So now, how did we evolve from these, from the traditional machine learning, the first generation of machine learning, to these X learning algorithm? So I'm sure that many people who teach machine learning today, they remember linear regression, logistic regression, artificial neural networks, reinforcement learning, but not more. But these are the type of what are called traditional machine learning. But when you look at this was the first generation of machine learning that we learned, all of us, before starting teaching machine learning. But among these algorithms or models, if I could call them, there are the neural networks, artificial neural networks, which gained some kind of momentum. It was a 3-layer model. It gained momentum when people started talking about deep learning. So when we move from neural networks to deep learning, it was the 3-layer model expanded to many layer internal layers. And that's when we started getting some breakthrough through deep learning. And there are quite a number of deep learning models today that we are talking about. And that's what I call the second generation of machine learning. So from deep learning, today, people are talking about federated learning. And that's what I'll be expanding more when I'll be talking about in the next session. And we'll look at, there are different ways of doing federated learning. So one of them is horizontal federated learning, another one, vertical federated learning, and the last one, federated transfer learning. And I'll explain all these models very shortly in the next sessions. But the most recent neural learning algorithm that people are talking about is split learning. And this is the newest one compared even, to federated learning. And these are things started, you'll see in the roadmap, that is started around 2018, which is very recent. So meaning that, every 5 years, we have some changes, something coming. And that's why I'm saying that. So in the near future, we might have another learning after the split learning, but we don't know yet what will be the name. And that's why I'm talking about X learning here. So now, let's look at the key features of all these learning algorithms. So the first generation of learning algorithm, so the features that we could identify is nonlinear modeling capabilities for the artificial neural networks, the ability to learn complex patterns and the relationship, the adaptability to different type of data, and the suitability for tasks like classification, regression, and pattern recognition. So when we went to the second generation, which is the deep learning, so that's when we saw ability to automatically learn hierarchical representation from raw data, high performance on complex tasks such as image and speech recognition, handling of large data sets effectively with deep learning, and but there was a requirement for substantial computational resources for training here. So in the third generation of machine learning, so we are talking here about now federated learning. And that is what is really the difference between the federated learning and the second generation of machine learning. Here, the first bullet here is the one that shows the difference. Preservation of data privacy and security by keeping data decentralized. Enabling training on heterogeneous data from different sources. Reducing communication overhead by transmitting model updates instead of raw data, and supporting large-scale distributed learning scenarios. And this is the big difference, the demarcation between like second generation and the third generation, which is federated learning. So now, when we are talking about the fourth generation, which is split learning, it allows also the preservation, privacy preservation by keeping sensitive data on edge devices, reducing communication bandwidth requirement, allowing edge devices with limited resources to participate in complex tasks, and supporting real-time and low latency applications. The future, as I said, we don't know what it will learn with. And that's why I'm talking about X learning or question mark learning. Because what I'll show now in the evolution now, you will see that, there is a kind of a roadmap where every 5 to 7 years, there is a change, something new coming. So now, let's look at the first generation of going from the first generation to the second generation. So all started in 1943, where we had the initial concept of artificial neurons proposed by Mark Callow and Pitt. So in 1975, we see that there was the first perception, a type of neural network which was developed. In 1986, the back propagation algorithm for training neural networks was reintroduced. And in 2010, we see advances in computing power and data availability, which is leading to the resurgence of neural networks known as deep learning revolution. So that's how we went from the 1945 to the first generation, which is called the deep learning. let's look at how we went from the second generation to the third generation. We are here in 2012. That's when we have the AlexNet, a deep convolutional neural networks, which achieved breakthrough performance in the ImageNet competition. In 2014, we start talking about generative adversarial networks, which are introduced by Ian Goodfellow. In 2017, we have the AlphaGo, a deep reinforcement learning model. We defeat the world champion Go player. And presently, there is ongoing research on deep learning architecture, interpretability, and transfer learning. In fact, when we are talking about the third generation, the third generation deep learning has not been replaced by the fourth generation federated learning. We'll see that even in federated learning, we are still using deep learning algorithm for doing federated learning. So now going from the fourth generation to the third generation to the fourth generation, in 2016, Google introduced federated learning for mobile keyboard prediction. In 2017, that's when we have the research papers on practical implementation and the extension of federated learning. So we must say that really federated learning started in 2017. And presently, there is ongoing research on security, efficiency, and scalability of federated learning. It's a hot topic. And I'm informing people that I have a big project on this with the University of Missouri and the University in Belgium, which is a free University of Belgium, where we are talking about deploying federated learning for smart agriculture and also for Energy 4.0. So now when we are talking about the fourth generation to the fifth generation, so in 2017, that's when split learning was introduced as a concept by Gupta and his colleagues. From there, in 2018, we have research papers on practical implementations and optimization of split learning. So currently, there is ongoing research on scalability, efficiency, and security of split learning. So now let's talk about federated learning. Can you still hear me, please? Hello?
Yes, we can. We can.
Okay. So now let's talk about federated learning. So the normal way that we do machine learning, normally we use, traditionally what we do, we adopt this gather and analyze centralized model of doing machine learning. Meaning that to do machine learning, you have a server somewhere and you collect data from elsewhere and you collect all this data so that you can give it to the server to do machine learning. But this has a problem of, first of all, limitation in terms of data delays. And also, I think that everybody heard about the POPI Act and GDPR in Europe. So we are not allowed anymore to just keep the data of people, on our servers. These people have the right, to remove their data on our servers. So, and this is the problem with the centralized way of doing machine learning. So the solution to that is to do what we call federated learning. So in federated learning, we still have a server somewhere, and we still have, some local servers, which we call clients, which have the data. In terms of federated learning, you don't need to move the data to where the server is. You leave the data locally, you say where it was being produced, and what you do, you move the model to the data. So it's kind of moving the compute where the data is located. So, and there is a 6 steps process, which is adopted when deploying federated learning. First of all, our server, which is in the center here, you see that we have the server here in the center. We have clients all over surrounding the server. So the model, the server will broadcast a model to the local client. Okay, so you see here the big pharma, the biotech startup, the academic lab. All these are kind of clients that we are using. So they'll receive a model from the server. When they receive the model, they'll do a local training, which is a kind of local optimization process. When they've trained the model, the result that they will have, the parameter that they will have, they will encrypt these parameters and send them to the global server. Upon receiving the parameters from the local client, the server will do what we call aggregation. It's kind of a global optimization that is doing there. It will do another aggregation here and send again the new model, which has been expectedly improved, to the local server. And this will be done in a number of rounds until we get good performance in terms of accuracy and losses. And that's where, when we see that, the model is acceptable, has good performance, the global model, that's when that we could start now the rollout and customization of the model itself. So that is in a nutshell how federated learning works. So instead of sending data to the server, is a server which is sending the model to the local client. The local client will optimize the model, will send the update to the server. The server will do aggregation, send the new model to the server, to the local client, and these steps will carry on for a number of rounds until we get good performance and we can now roll out the model and customize it. That's how federated learning works. So now there are different types of federated learning. Currently, what is the most used is a centralized way of doing federated learning, which is represented here on the left-hand side. It means that you have a central server which is distributed the model to all the clients. But now people are talking more and more about decentralized federated learning, where we don't have a central entity, the server itself, which is distributing the model, but rather we have different entities in a different distributed way, different entities which are sharing the model in a distributed way and doing the aggregation and so on. So this is one way of doing federated learning, and an alternative way of doing federated learning. So now, there are different types of federated learning. You understand that when we are doing everything which is learning, machine learning, we rely on the data, isn't it? We rely on the data. And in fact, this data that we have in different, the data that different clients have may be, let's say, overlapping on features, for example. It may happen that on features, so these data is overlapping on features. So let's say there's some hospital which has different branches in different cities. And in this case, I mean, when we are doing, I mean, the machine learning, the different clients will have the same features. The data set that we are using, they have the same features. But obviously, the client must be different, but the same features. And that's what is represented here. So when we are doing this is what we call horizontal federated learning. So it means that the way that, I mean, federated learning is applied is on a data set of clients which has an intersection on the future samples. So a second way of doing federated learning is vertical federated learning. Here we are not talking about features, intersection on the features, but is much more intersection on the identities. So it's as if in a city, you have a certain number of people, I mean the same people, and but when we are dealing about their data in the banking institution, the insurance companies, and medical aid, for example. In this case, we are talking about federated, vertical federated learning, where the intersection is not anymore on the features, but is much more on the identity of this identity in the data set. The last one is federated transfer learning. So in federated transfer learning, we don't have neither intersection on the features nor on the identities. And in this case, we talk about federated transfer learning. So these are the three types of federated learning. Before the fact that, I mean, they can be deployed using a centralized topology or a distributed topology, as I showed before. So just to show you a kind of deployment scenario. So as I said, I'm working on Energy 4.0. Two of the projects that I'm working on is Energy 4.0, and another one is Agriculture 4.0, which is just smart agriculture. So the way that I mean federated learning should be working, I'll have a global model here, and I'll have local models in a different clients, isn't it? So this is just another representation of federated learning. So now, in case of Energy 4.0, we are trying to look at different topologies, scenario that could apply in terms of energy, smart energy. Let's suppose that I'm trying, to look at how different solar systems located in different client location could be analyzed. And this is one of the ways that we could be using. So you're going to have one edge computing node per household. So it means that you see that you have different households which are clients, isn't it? And you see that each household has one edge computing node. So this is forming a client, this is forming a client, and so on. So and obviously, these edge computing nodes are interacting with the server here for the global model and so on. So another scenario could be you have one edge computing node per neighborhood. Okay, this is another way of doing federated learning in this case. So in this case, the potential scenario could be, let's say, transfer learning that you are deploying here. Another way of doing federated machine learning for Energy 4.0, you have one edge computing node per building. So in case that you have a lot of a number of buildings, you can have for each building one edge computing node, one edge computing node, and so on. So this is just to show you some of the scenarios that could be applied in terms of federated machine learning. Please tell me when I have to rush, because I assume that I've consumed a certain number of minutes already.
You may finish off, Prof.
Hello, I should finish off now?
You can finish off, Prof. I think you still have a few slides to go through. I'll give you an extra 5 minutes.
It's okay. It's okay. 5 minutes could be okay. So now, another thing that I'm working on a model of federated learning for Africa. By taking into account that normally, according to the African Union, the African continent should be subdivided into 5 regions. And from these 5 regions, there are ways that, we could be looking at. Let's say we have, these are kind of different client nodes in 5 different regions, and doing all type of studies. Let's say when the Ebola eruption arrived, we could have deployed kind of a federated machine learning for Ebola research in Africa. So now there are different real life applications which have been there. In terms of machine learning, deep learning, federated learning, and split learning. So I'll just cover this very quickly. You could see the different areas of application where these machine learning have been deployed. This is machine learning, deep learning, where they've been deployed. But look at the split learning. Split learning is focusing much more on edge computing, healthcare, and industrial applications. While federated learning, what they say is much more mobile devices, Internet of Things, healthcare. Obviously, there are other applications where this has been deployed. Because when you talk about Internet of Things, you're looking at many things. Internet of Things can be deployed in any area nowadays. So now, just talking about one of I'll expand a little bit just for the last 3 minutes that I have on selective federated learning. So federated learning, as we saw, the deployment is in 6 steps. It's as if you have the global model, which is controlled. Let's consider an example of a football team. A football team participating in a tournament. The key players are who? They are the player themselves and the coach. So the coach has the possibility of either aligning everybody, all the players, after each training, he will align all the players, and by maybe a full round robin or something like that, he brings all the players for each match. And all the players will be playing maybe 5 minutes and so on. So, but he can say also, okay, wait a minute. I realize that all my players don't have the same strength. For this tournament, I'll be doing what? First of all, go for training. When we do the training, we'll select the best students, the best players, and it will be these best players who will be aligned for any match. So this is what the difference between normal federated learning and selective federated learning. So now, the whole idea of federated learning and many of the algorithms are derived from what we call federated averaging, and which has been improved in order to do some kind of selection among the clients. So it means that when you are training, when you are doing, federated learning, each round is not all the clients who will be participating in the aggregation. You select only the best clients to be participating in the aggregation. And this is a way that you can have better performance in terms of accuracy, losses, and also sometimes in terms of runtime, complexity, time complexity of the algorithm. So what we did here, I'll just, present you some results that we did in terms of, we compare, 3 algorithms, selective federated learning algorithm. And here we are interested in much more the attack, the security part of it. So what we did, we launched attack on these models. It was kind of attack. What is type of attack? We launched a model poisoning and also data poisoning on these models. And we saw how the model reacted. So I'll not expand more on this. For those who need much more information, we could maybe talk about it offline. But yet, you could see here from the result that you could see that some of the model like Fed AVG and Fed Prox perform better than Fed ADA-GRAD. So, and here the same also, it can show the same. So the lesson here is to say that when you'll be deploying, these models, federated learning models, you have to be careful. You look at what is the model that you'll be deploying for your deployment. You'll be considering for your deployment. Some of the models are much more powerful than the other. They produce much, they lead to much better accuracy and less loss. And some of them are much more resilient against the attack than the others. So I'll conclude here, and thank you very much for giving me the opportunity to talk again. Thank you.
Thank you, Prof. We've been educated and we are even yearning for more knowledge. So I'll only pose one question from the audience online. Someone posted a question and you will respond to that. Then for the rest of the participants, we will share the contacts for Prof. Bakula if you have further questions. So the participant says with federated learning, the data is stored across different multiple machines or servers. What if these data sets are not uniform? Does this method come with tools or techniques to make it easier to incorporate the different data sets, to have one structure to avoid data heterogeneity?
So this is really effectively the problem that federated learning is solving. So you understand what is happening is the data heterogeneity that it's solving. Obviously, through aggregation, you understand that the server will send the model, the global model. These different clients will use this global model to train their data set, local data set. The parameter that they will find will be sent to the global model, to the server, which will improve, taking into account all these parameters that were found based on the local models. So the model which will be sent at the second term, it will be a much more improved model, and so on, until you carry on, until you get a global model which is better for all the clients. So it's in fact heterogeneity of data which is being solved here, the problem of heterogeneity of data.
Thank you so much, Prof. I have someone who is bullying me here and insisting that they want to say something. I wonder why we have such police.
It's just a follow-up question. It's just a follow-up question.
Yes.
The exchange between the central server and the clients. So when the server sends the first model, how does the client adjust the local model based on the data, the features that it's dealing with?
He's not adjusting even the local, he doesn't have any local model. It's a global model which become the local model. So he just, train with the model that he received from the server.
So the features will be the same because the model would be
heterogeneous data set.
Yeah,
it's the heterogeneous data set. So you might miss certain features. You might have certain features here and there.
I think, Prof, you were supposed to have been in video, so that we can have this debate. There will be a heterogeneity is going to be to have an impact since the features are different.
Yeah, same features.
Please.
All the clients will have to have the same features.
Yes, that's it. So
yeah, so in terms of it, even if the data is heterogeneous, that it's from different sides, but the parameters would be the same.
Yes, for horizontal, please,
So
for
it's going to be
horizontal.
the left side, you are looking at images, that side, you are looking at textual, there's no.
Your scholars are sitting here, they are defending.
Yeah.
And they are busy defending your position. I don't know whether it's part of the research cluster or what's happening here.
So can I explain, please? The way that I explain it, I explain the horizontal federated learning. So it means that all the features are the same. But remember that I said there are other types of federated learning.
Yes. But I understand your point, bro. If it's heterogeneous,
Yes, so
I understand your point. It's not
I think Jose needs an interaction with you. I'm inviting you to the ETNCC conference, Prof. I know you're one of the committee members, so you can come for a week in Windhoek. You're even a keynote speaker, better still, and we can iron out this. Do you need a session to discuss this? Maybe I should put up a panel discussion so that you can iron out these differences.
No, I will come. I can come.
Thank you, Prof. Guy and Jose are going to organize your flight ticket.
Okay, thank you very much.
Have a great afternoon.
Okay, you too. Bye-bye.
Bye. So some two culprits have gotten themselves into trouble, right? And one, the program